So in order to find the displacement of the car, we will need to use the equation for work is equal to force times displacement solved for d, which would be equal to work over force. Now first, in order to use that formula, we have to find the applied force. So we do this by setting up a triangle representing the hill and the forces acting on it. So using the angle of the hill as 35, we can find that angle formed by the vectors of gravity and the applied force here, which is equal to 55. So then we use this projected vector to create another triangle. So we know that the magnitude of the value from the object at the intersection of the vector and the hill is the applied force here. And so using this knowledge, we can use this triangle that formed to find the value of the force in the formula. So in order to find this force, we use the angle 55 and the knowledge that cosine is equal to the adjacent sine over the hypotenuse to solve for the value of x, or the adjacent side of the force. So now that we have the value of that force, we can then plug that force into the equation for the displacement, and d equals work over force, and using our values, work being that original value we determined for the work, we can find the displacement or the distance traveled, which ends up being 49.813 feet.